So today we're going to talk about limits, and we're going to look at limits graphically. So a function is said to have a limit L at C. So now we're looking at a specific location. Up to now we've looked at infinity and negative infinity, but we're going to be looking at a specific value. And there is a limit provided that the sequence of f of x, the y values, approach this L as x goes to c. So the notation here is the limit as x approaches c of f of x equals L. So c is some x value that we're approaching, and L is the y value that the function is looking at. So basically, is there a value that it approaches as x gets close to c? I'm going to zoom in to these two, and I'm going to talk about this information. To investigate a limit both graphically and numerically, what we're going to do is do a left-hand limit and a right-hand limit. So the left-hand limit is as x approaches c, and then there's a little negative there. That doesn't mean negative c, it means c from the negative side. The right-hand limit, we're going to look at values as we approach c from the right or from the positive side of the graph. And the limit, so if the limit from the left and the right are the same, then the limit exists and is L. Now we're going to talk about some properties, and these are going to be fairly straightforward. The sum property. So we have two functions, and we're adding them together, and we're looking at the limit as x approaches c of f of x plus g of x. Well, that's going to equal the limit as x approaches c of f of x, and we're going to add that to the limit as x approaches c of g of x. Same is going to be true for subtraction. So if we're adding, we can add them. If we're subtracting, we can subtract them. This one, this k, is a constant. So this limit is going to be k times the limit as x goes to c of f of x. Multiplication and division are going to follow. So if we're multiplying the two functions, we can multiply the two limits. If we're dividing the two functions, we can divide the two limits. A power, this will be the limit as x goes to c of f of x to the n. And lastly, a composition. So the limit as x approaches c of f of g of x is going to be f of the limit as x approaches c of g of x. Okay, now we're going to look at limits graphically, and a good way to illustrate this idea is with a piecewise function. So we have two piecewise functions here. First thing we're going to do is define the equations. We don't need that to do the limits, but it's just good practice. So for f of x here, we have 4 distinct parts. I'm going to start with the x values, and then I'll fill in the functions. So this first one goes from -3 to -1, and I include both of those because they're closed dots. The next one goes from -1 to 1, non-inclusive because they're open dots. 1 to 2, and finally 2 to 3. Then we'll just write the equations of the lines. So this first one has a slope of -1 because it's going over 1, down 1. So this will be a negative x. And then if I continued it to the y-axis, or to the y-axis, it would cross at 0. So it's just going to be negative x. Here is just 0. This one has a slope of 1, and if we continued it, it would go at 0. And then this one's going to be 3. Okay, we'll do the same thing here. So we have something from -3 to 1, -1. We have something at x equals -1, going from -1 to 1, and this one, we can include the 1 on either this graph or this graph, or equation. Then we'll fill in the formulas. So this is just going to be a horizontal line at 2. At 1, we're at 1. This one, we're going down 3 over 2, so that'll be a negative 3 halves x, and that's going to cross right in the middle there, so plus 1/2, and then a y value of negative 1. Okay, so now we're going to look at some limits. So these first 3 are all the function f of x as we approach negative 1. It's whether we're looking at negative 1 from the left, negative 1 from the right, or the limit for negative 1. So when we're looking at the limit as we approach negative 1 from the negative side, so we're approaching this location. The limit, we don't actually care what is happening at negative 1. So I'm actually going to cover this up. Okay, so this one, as we approach from the negative side, these y values are approaching 1. From the positive side, I don't care about anything over there. As we approach negative 1, we're on this location here. Well, those y values are approaching, or in fact are, 0. So from the left, it's approaching 1. From the right, it's approaching 0. If these two are different, the limit does not exist. Now we're going to do that with g of x. So here's my graph of g of x. And these are just the graphs that are up at the top of the page. I just moved them so you can see them. So again, we're looking at negative 1 from the negative side, negative 1 from the positive side, and negative 1. So here, as we approach negative 1 from the negative side, again, I'm going to cover this up. Okay, this line is approaching 2. From the positive side, this side is also approaching a y value of 2. So if the left-hand and right-hand limit are the same, the limit exists and is 2. Well, that's a little bit funny in this case, right? Because there's this dot that's not at 2, but we don't care what's happening at that single location. This graph is approaching the same thing from the left and the right. So the limit exists if it's approaching the same thing, not necessarily what's happening at negative 1. Okay, now we're going to do some operations. So the limit as x approaches 0 of f of x plus g of x is going to equal the sum of those two limits. So f from both the left and the right is approaching 0. So this is going to be 0. And g of x is approaching from both sides that same location of 1/2 as x goes to 0. So this limit is going to be 0 plus 1/2, which will be 1/2. Here we're going to multiply. So as we go to negative 2, it's approaching the same thing from both sides. It's approaching 2. G of x is approaching also 2. So this limit will be 4. The limit as x approaches 2 from the negative side. So I encourage you to practice these three. Pause the video and see if you can get these without my help. Okay, now we're gonna see if you did it right. So we're gonna look at 2. So from the negative side, 2, as x goes to 2, my y values are going to 2. From the positive side, as x is going to 2, my y values are going to 3. Those are not the same, so this limit does not exist. And graphically, it's really easy to tell if the limit doesn't exist. Okay, if there's a jump, if there's a break in the graph where it just all of a sudden is at a different place, there's no limit here, there's no limit here, there's no limit here. If it's approaching the same thing, then the limit exists. So for g of x approaching 2, it's approaching the same thing from the left and the right, which is negative 1. Here the limit as x approaches 0 of 2 times g of x. So g of x is approaching 1/2. So 1/2 times 2 is 1. This last one, for the composition, I'm going to rewrite this as f of the limit as x goes to 0 of g of x. Okay, then I evaluate this limit. So this is going to 1/2 again. Then I'm going to go to the graph of f at 1/2, which is right here, which is 0. Okay, now we're going to look at some different equations. So we're going to do 1 over x. This is one of your parent functions that you should know how to graph by hand. So 1 over x, 1 over 1 is 1, 1 over 2 is 1/2, 1 over 1/2 is 2, and then it's going to approach the x and y axis, and then it's going to repeat that down here. Okay, so here we're approaching 1 over x. We're approaching 0 from the negative side. So those values are going to negative infinity. As we go to 0 from the positive side, it's going to positive infinity, which are definitely different locations. So this limit as x approaches 0 does not exist. What about at infinity? So as we go to infinity, those values are approaching 0. As we go to negative infinity, those are going to 0. Okay, new graph. So we're approaching -2 from the negative side. So here's -2. From the negative side, those are going to infinity. -2 from the positive side is negative infinity, which means that limit wouldn't exist. If we went to x equals 1, this limit, okay, here at 1, it's going to negative infinity and negative infinity, but there's an asymptote there. So if it's approaching that, we'd either say does not exist. I would also accept negative infinity because it is going to that from both directions. But typically we reserve that for just the one-sided limits. And then what are we approaching as we go to infinity? 0. And negative infinity, 0. So the limit as x approaches 0 of the absolute value of x. Remember, absolute value just looks like that, right? So as we approach 0, this is going to 0. Now we're going to look at as we approach 0 of this function here. So this is the absolute value of x over x. So if I plug in a number like 1, we have 1 over 1, which is 1. If I plug in 2, we get 2 over 2, which is 2. If we plug in 0, it's undefined. So I'm going to do an open dot here. And for values here, they're all going to be 1 because it's just going to be the same thing over the same thing. If I plug it in a negative value, I'm going to have a positive number over a negative number. So like -2, this would become 2 over -2, which is going to be -1. So this is going to look like that. Okay, so if we look at the limit as x approaches 0 from the positive side, that limit is 1. As we approach it from the negative side, we're at -1. Those are not the same, so the limit does not exist. And again, graphically, that's really clear. There's a big jump, so the limit doesn't exist unless they're approaching the same thing. And then what about the limit as x goes to infinity? That is 1. For these next two, we're going to graph them in the calculator and look at what happens. So we're going to look at initially x sine x. Make sure that your calculator is in radian mode here. If you're in degrees, the graph's going to look kind of funny. So we're in radians. I'm just going to do a zoom standard. Okay, well, what's happening don't know, let's maybe increase our y values. So rather than going from, or x values, let's go from negative 20 to 20. So we're examining the limit as we go to infinity. Well, this thing is just going to keep oscillating back and forth and back and forth and back and forth. So this limit does not exist. Okay, let's look at this guy as x goes to negative infinity of all of this. So we'll type that in the calculator. One trick, if you have an 84, is if you hit the alpha button, there's these shortcut menus. In F1, there's a fraction. So if you do this first thing, you get a fraction bar, so that separates that out. If you don't, then you're just going to have to put the top in parentheses and the bottom in parentheses. So this is going to be 2 to the x plus 2 to the negative x all over 2 to the x minus 2 to the negative x. We'll graph it, and we'll adjust our window if we need to. So we're looking at this graph as we go to negative infinity. So those things are approaching an asymptote, which appears to be at negative 1. Okay, now we're going to graph another piecewise, and I'm actually going to show you how you can do this in your calculator. So we're going to graph this piecewise. You're going to type it in like this. So you have this equation, this range, this equation, the domains, and then you put addition in between them. So it has to be exactly like this. To get the inequalities, you're going to use the test menu. Okay, so we're going to have, open parentheses, 2x minus 1, open parentheses, x. To get that less than or equal to above the math button, there's a test. So we do second test, and then we get all these inequalities. We want less than or equal to negative 1, close, plus 2x plus 3 when x is greater than negative 1. I'm going to do a zoom standard. Okay, so from this graph, as we're approaching negative 1, it's not approaching the same thing. So this limit isn't going to exist. We can tell that already. And we can use the graph to arrive at that. You can also do this numerically by filling in the chart. But we're going to do more of that next class. So for right now, I'm just going to use the graph. As we approach negative 1 from the negative side, we're going to a negative 3. As we're approaching negative 1 from the positive side, it's going to 1. Those are not the same, so this limit does not exist. The figure above shows a graph of a function with a domain from 0 to 4. Which of the following statements is true? So the limit as x approaches 2 from the negative side exists. Yes, it does. As we approach 2 from the positive side, that exists. But are they the same? No. So statement 1 is true, statement 2 is true, statement 3 is not. So our answer here is C. And finally, for which of the graphs does the limit as x approaches 4 of f of x exist? So we're looking for, does it approach the same thing from the both sides? And yes, this one does. Even though there's a dot and a hole there, the limit is going to the same place. Same thing here. We're going to the same place. Even though there's a hole, that limit exists because it's approaching the same thing. Here, it is not. okay, because they're going to two different locations. So this one is, again, 1 and 2 are correct, but 3 is not. Thank you for learning limits graphically.